The metals are on the left side of the table. They tend to form cations. Properties of metals include luster, that is, metals tend to be shiny. Metals are also ductile, which means you can pull them into wire, particularly if they've been heated a bit. Metals are also malleable. That means that they can be hammered into shape. You can almost see the word mallet right there in the word malleable. Metals also tend to be good conductors, both of heat and electricity. And the reason for this, which we'll discuss later, is because metals have mobile valence electrons that are free to move throughout the entire crystal structure. Because of their low ionization energies, metals are often oxidized in reactions. And of course, oxidation, what's the mnemonic? Leo-ger, losing electrons, oxidation, gaining electrons, reduction. Metals tend to lose electrons. The metallic character of the elements increases as we go down and to the left on the periodic table. Up here we have lithium, element number 3, and down here we have cesium. Both are metals, but cesium is more metallic because it's lower down. If we go to the other side of the table, fluorine is up here, and iodine is right down here in the lower right. While both are non-metallic, iodine is slightly more metallic. Metallic character increases as we go down and to the left. Another way of saying that is non-metallic character would increase going up and to the right. Nonmetals, then, are on the right side of the table. They tend to form anions. Properties of nonmetals are that they tend to be good insulators, and in elemental form they tend to be gases or brittle solids, as opposed to metals, which you recall tend to be ductile or malleable solids. And metals at room temperature are never gases. So here are some examples of some nonmetals. Neon, of course, is a gas at room temperature. Sulfur is a solid. Iodine is a purplish crystalline looking solid, and bromine is a liquid at room temperature. We need to make sure that we memorize the Hobberfinkel twins. These are the diatomic elements. They were covered in an earlier lesson. Hobberfinkel is a very easy mnemonic to remember. You can have a little bit of fun rearranging those letters and making new words if you want. One of those would be Klaberhyphen. Now it's best if you say this with a German accent. Klaberhyphen. And here we have Hans and Franz, the Klaberhyphen twins. Wer sind sie? Die Klaberhyphen Zwillinge. So, these are the diatomic elements. When these are in elemental form, they are in pairs. Two atoms holding hands, going around as a couple. The metalloids, or semi-metals, are the stair between the metals and the non-metals. So they are located on the periodic table between the metals, which are on the left and at the bottom, and the non-metals, which make up basically just a little triangle in the upper right corner of the periodic table, as well as hydrogen way over here in the upper left. Hydrogen is a non-metal as well. The metalloids make up this stair step. That kind of makes sense because metalloids, they're kind of metallic, but they're kind of non-metallic. So their properties are in between those of metals and non-metals. The metals are conductors. Non-metals tend to be insulators. Metalloids, sometimes we call them semiconductors. In particular, silicon and germanium are very important to modern computer technology. Here are some of the different regions of the periodic table. The alkali metals are the group 1 elements, except hydrogen. Hydrogen in the upper left is not an alkali metal. The alkalis tend to lose one electron, and they are quite reactive. The alkaline earth metals are the group 2 elements. They lose 2 electrons when they become cations. They're not quite as reactive as the alkalis, and we could rationalize that by saying that in order to react, the alkaline earths need to lose 2 electrons, and the alkalis only need to lose 1, and it's easier to lose 1. The transition elements are groups 3 through 12. They have variable charges for the most part. Another name for the transition elements is the D block. The chalcogens are the group 16 elements. They are topped by the element oxygen. They tend to gain 2 electrons, acquiring a 2- charge. They're quite reactive. The halogens are just to the right of the chalcogens, group 17. The halogens all tend to gain 1 electron and are quite reactive. The noble gases are on the far right side of the periodic table. They don't want to gain electrons, they don't want to lose electrons, and so they are comparatively unreactive. In fact, for quite a while, they were called the inert gases because it was believed that noble gas elements never formed compounds and were thus inert. But several compounds of the noble gases have been formed, so they're not called the inert gases anymore. They're called the noble gases because back in the day the nobles held themselves apart from the rest of us like the noble gas atoms tend to do. The lanthanides and the actinides are down below the main body of the periodic table. The lanthanides are elements 58 through 71 and the actinides are elements 90 through 103. Those two regions collectively are sometimes called the F block because those elements contain F orbitals. And finally, the main block, or representative elements, are groups 1, 2, and 13 through 18. In other words, the S and P blocks. What we'll do here is we'll show some of these different regions. On the far left, we have the alkali metals, except hydrogen is not an alkali metal, so you notice that it has been colored in a different color compared to the other alkali metals. Right next to them we have the alkaline earth elements. This middle part of the table, those are the transition elements, sometimes called the D block. Then if we go to the right side of the table, this green column is the chalcogens, then this violet column is the halogens, and we have the noble gases on the far right. Down at the bottom we have the lanthanides, which begin with the element lanthanum. Lanthanum is right here, and after this element right here we go immediately down to right there. So these are called the lanthanides, and these are the actinides, and this element that I'm circling right here is actinium, and right after actinium we go right down to there. So that's fairly easy to remember which of these rows on the bottom is the lanthanides and which is the actinides. And then the main block, or representative elements, are collectively the S and P block. And they're called the main block or representative elements because as a whole they are a representative sample of pretty much all the properties that elements can have.